Okay, so as we said on Friday, kind of the key concepts, yeah, there's going to be some V equals D over T stuff, but not really in the problem solving per se. We need to know scalar and vector quantities so that if a question is asking for a scalar quantity, we can recognize that that's what it's asking for, okay? Especially to do with graphing, which we also said was a big deal, okay? There's going to be a lot of graphing stuff, either interpretation of graphing or calculations to do with graphing, like y equals mx plus b, okay, stuff like that. There could be some acceleration problems on there. There's definitely going to be work energy theorem problems. Okay, we spent a great deal of time on work energy theorem. Conservation of energy, like the roller coaster questions. Okay, that will definitely be something that's on the final exam. We also talked about the types of energy, the laws of thermodynamics, types of systems, okay, and things of that nature. So that's the kind of stuff that is going to be on there. Now we said some of that's going to be just multiple choice. So if it's something that was a lot of notes about it or something like that, that's going to be multiple choice. If we spent a lot of time solving problems, working on worksheets or doing labs, that's the kind of thing that's going to end up in the written response. So graphing, obviously a big one, okay, work energy theorem, a big one, conservation of energy, okay, all of those things we did labs on, okay, in this unit. So, what kinds of questions do you guys have to start off with? What kind of things do we want to go over? Okay, so work energy theorem questions. So let's say, oh, sorry, my writing's awful there. Required Okay, so question's asking what force would be required to act over 12 meters if it's going to accelerate a 200 kilogram mass from 2 meters per second to 10 meters per second. All right, so we said anytime we are encountering a work energy theorem question, okay, we know first off that work is a change in some kind of energy. We need to identify which kind, potential or kinetic. It's kinetic because it has to do with speed, right? It doesn't say anything about making the mass go higher, okay? It just talks about making it go faster. So that means that we are looking at a change in kinetic energy. All right, the way to calculate work, force times distance. The way to calculate the change in anything is final minus initial. Okay, do I have a formula that calculates kinetic energy? Do we know what it is? If we don't know what it is, that is definitely something we should be studying so that we recognize what it is on your formula sheet. Right, 1/2 mvf squared minus 1/2 mvi squared. All right, so that's going to find our change in kinetic energy. All I have to do is solve for force, which means what do I have to do with distance? Divide it over to the other side. Okay, so when we plug in our numbers here, okay, we're going to have that the force equals 1/2 times 200 kilograms times 10 squared minus 1/2 times 10 kilograms times the 2 squared. Yeah. Okay. Divided by 12 meters. Okay. All right, so that's going to require, so that's the change in energy, divide that by 12. Okay, it's going to require 800 newtons worth of force. Okay, questions on how that one worked? That's a pretty standard work energy theorem question that we would have done in class. That one for kinetic, okay. We can look at one for potential if you guys want. Do you want to look at one for potential? I think I put 200 in my calculator. I did. I don't know why I wrote 10 there. I wrote 200 in the calculator where it mattered. But yes. Okay, let's look at one for potential energy then. Okay, so we want to find the final height of a 15 kilogram, 1.5 kilogram rock. If it's thrown, what was that writing over there? I don't know what okay, if it is thrown from ground level by a force of 95 newtons over a 2-meter distance. I'm going to give you guys a couple minutes to try that one before I do it on the board. Okay, it's a work energy theorem problem. This time it's to do with potential energy. All right, so as we said here, we're looking for a change in potential energy. So the work being done is going to change the potential energy here. Right, the stuff we know the force, 95 newtons. We know the distance over which it acts, 2 meters. We know the mass, 1.5 kilograms. Okay, and we know that it's thrown from ground level, which means our initial height is 0 meters. All right. So we have force times distance equals m times g times h final, so our final potential energy, minus our initial potential energy, okay, because that's what delta means. Now, since our initial height is 0, how much potential energy do we have initially? 0, which means we don't even need that part of the equation. We can just write that force times distance equals mghf. So I'm being asked to solve for HF. What I want to do then is divide both sides by m times g. All right, that'll leave me with HF. So I put in my numbers here, 95 times 2 meters divided by 1.5 times 9.81. Okay, so we are looking at a final height of just under 13 meters. Right, so 12.9 meters. Right, so those are exactly like the work energy theorem questions you had on your physics unit exam. Okay. All right, what else do we want to look at? Conservation of energy. Okay. Okay, I want you to take the information here and find the initial height of the hill. Okay, so at the top of this hill, okay, well, the object is moving at 2 meters per second. Here, 5 meters above the bottom of the hill, it's moving at 22 meters per second. Okay, I want you to calculate the height of the hill from that information. Okay, mass of the trolley or the cart or whatever we'll say is 150 kilograms. All right, so what we know is that the amount of energy is the same at the top of the hill as at the bottom of the hill. It's not the same kind, but it's the same amount of mechanical energy, top and bottom. Right? So at the top, we have some kinetic energy because we're moving, and we obviously have potential energy because we're at the top of a hill. So we're going to have m times g times h initial plus 1/2 mv initial squared equals, mghf plus 1/2 mvf squared. Right? We're looking for this, for hi. Okay? I gave you the mass, but do you need it? No, it's in every term, so we can cancel it off. If you're not comfortable with that, leave it in, put in 150 for it. Okay. All right. Again, I'm trying to get hi by itself, so I first want to subtract the 1/2 vi squared over to this side. All right. So I'm going to have ghi equals ghf plus 1/2 vf squared minus 1/2 vi squared. Okay. And then I want hi by itself, so I divide both sides by g. Okay, so what I'll have is that the initial height equals 9.81 times 5 plus 1/2 times 22 squared minus 1/2 times 2 squared divided by 9.81. All right, so it's just a matter of getting the manipulation right on this one. So 9.81 times 5 plus 0.5 times 22 squared minus 0.5 times 2 squared, okay, divided by 9.81. All right, so this thing is going to be 29 meters above the bottom when it starts. Okay. Questions on that one? Okay, we did a whole bunch like that, a bunch of roller coaster questions that were essentially the same as that back in the unit. Okay. All right, what else do we want to go over? Jess? An acceleration question? Mm-hmm. Oh, no, hang on. That's not big enough. Okay, sorry, I forgot to put vectors on those. Okay, they're vector quantities, so I had to put vectors on them. All right, so we're looking for the initial velocity of the plane. Okay, I'll give you a couple minutes on that one. This one. So first thing we want to do is write down our givens, right? We know the acceleration is 3.0 meters per second squared north. Okay, we know the time is 12 seconds, and we know that the final, sorry, that should say velocity. Okay, the final velocity is 68 meters per second north, right? We're looking for VI. So A equals VF minus VI over T, right? That's the formula we have to use here. So the first thing I'm going to do is multiply both sides by t, okay? And then I'm going to add vi to both sides. So I'm going to have vi plus t times a equals vf, right? I'm looking for vi, so now I'm going to subtract t times a over to the other side, okay, and solve for vi. So vi will equal 68 minus 12 times, is it 3 seconds? Yeah, yeah, 12 times 3. All right, so 68 minus 36 should be 32, right? Okay, 32 meters per second north, because it did ask for velocity, which is a vector quantity. That's one of those things you'll have to watch for. Okay, remember I was telling you that you need to know which things are scalar and vector so that you remember to put a vector on quantities that you solve for that are vector. Okay. All right, what else, guys? We've already, like, mechanical energy is like conservation of energy or work energy theorem. They both involve mechanical. The only thing to remember about mechanical is it's the sum of kinetic and potential.
Usefulness or efficiency.
Efficiency, okay. Okay, so an efficiency problem. This engine or motor operates at 25% efficiency and it uses 365 joules of input energy. How much useful work does it accomplish? So what we have to remember is that efficiency equals our useful work over our input energy. Okay, so if I'm solving for useful work, I'm going to multiply the input energy by the efficiency. Okay, so that's going to be 0.25, because we always have to convert the percentage back into a decimal, right, times 365 joules. Okay, so it's going to do 91.25 joules worth of useful work. Okay. I would say don't expect anything more complicated than that probably on your, and it would only be in the multiple choice part of the test anyway. There's very, very little on efficiency on your final exam. All right, what else, guys? Okay, like in terms of what? Graph? Okay. What kind of graph? Position time or velocity time? That's supposed to be flat. How about I draw that looking flatter? Okay, so from that velocity versus time graph, calculate the total displacement of the object. I'll give you a couple minutes on that one. Okay, so the key to these is that we essentially have to use that the average velocity, okay, times the time is going to give me displacement. In a place where the velocity is not changing, that's easy. It's just base times height. Okay, that's time times average velocity. That's easy. In a place where it's accelerating, okay, that's it's changing its velocity. The average velocity occurs at the halfway point of the triangle. That's why we use base times height over 2. So essentially, we're finding the area underneath because that allows us to take the average velocity multiplied by time. All right. So first thing is, let's identify the shapes for calculating the area of. If it was me, I would do this big long rectangle here. I would do this rectangle here. Obviously this triangle, okay, and this little triangle right here. Those would be the areas that I would calculate. So for this long triangle here, it's 9 seconds on the base and 2 seconds high. So it's 18 meters. Okay. This rectangle here is 3 high by 3 long, so that's 9 meters. This triangle here is 2 seconds long by 3 seconds high, and you divide that by 2, and you get 3 meters in there, right? And then this little triangle here is 1 high by 1, or sorry, is 2 high times 1 is 2, divided by 2 is 1 meter. All right, so we've got 27, 30, 31 meters would be our total displacement. And we should probably write that that's positive because displacement's a vector quantity. Okay. All right, what else, guys? No, not much. Like I'm not going to ask a lot of questions about people and places and whatever. Maybe know they're really important, like Joule. You know, he's pretty important. Other than that, not really. No, I'm not going to ask too much about the history on here.
More like the different like questions you kind of asked us in the beginning, like the ones about fusion.
Yes, yeah, the types of energy, yes. There's going to be stuff, well, there's not much to go over. You have to kind of go over your notes on that, okay? You need to know the types of energy. There's chemical energy, there's nuclear energy, know those. Know the types of systems, open and closed. We talked about that on Friday, right? Okay, so we got to know open, closed, and isolated. We've got to know, mechanical energy is the sum of kinetic and potential, okay? Things like that. There's nothing really new. That's going to be multiple choice stuff. Okay, what else? Like that's really about the only notes stuff that you have to read over for this unit. Yeah, Luke? We just did one with that. Yeah, this one here. Yeah, we don't have like that's always, it's always average acceleration. We don't have any ones where the Okay, we can do one like that. Yeah. Whoop, interval only has one L. Is this what you meant, Luke, or did you mean a graphing question? Okay. So what we have here, we just write down VI is 12 meters per second. VF is 30 meters per second, and the time is 7 seconds. Right, so A equals VF minus VI over T. We don't manipulate it, already solves for A. Right, so we just have to go 30 minus 12 over 7, so that's 18 over 7. And so it's 2.6 meters per second squared. Jace? Yep. Okay, anything else there, guys? Okay, well, I'll give you a little bit of time to look over the review package. I'll pull it back up and put it up here on the board. Okay, but you got the review package, you've got your stuff from during the unit. Okay, there's a bunch of worksheets in the workbook from that. Okay, but before we get to that, a couple of things. What do you need to bring to the test with you? Calculator, and your calculator should either be charged or have fresh batteries in it, one or the other. Okay, what else? 2 pencils and 2 pens, right? What else?
Fully charged calculator. Fully charged.
It's like there's an echo. I just heard myself say that like 5 seconds ago. Okay. So pencils, pens, calculator. That's it. Okay. Unless you're bringing water and food. Okay. If you are bringing those things, make sure that you have them in, a resealable container so they don't spill or make a mess or whatever. Okay. Remember, you can't bring your phone. Okay. So find a place for your phone. Do not have it on your person in the exam. If you are caught with it, that's an automatic 0. Okay. So don't bring it in there. Okay. We don't want to have that situation happening for you. Okay. Your exam is at 9 in the morning on the 26th. Make sure you are here for shortly after 8:30. Okay, like normal school arrival time is what time you should be here. And then at 8:45, okay, they'll open the doors. You look at the whiteboard, find out what row you guys are in. They will be laid out in alphabetical order, starting from the far west wall of the gym. Okay, so the A's will be at that end. Okay, they'll go in alphabetical order back from there. Find your test, sit down. Don't open the test. Right? They'll tell you when to open the test. Just sit down for them. Okay. Inside of the test, you will find your multiple choice answer form and your periodic table / data sheet. It's all together. It's double-sided. All right. So you shouldn't need to tear any pages off of the exam. All right. Just use the exam booklet. You can write all over it. Multiple choice section. Don't care. Write all over that exam. It's only being used for you. Okay. I don't reuse them. All right. So write all over it. Make sure you show all your work, okay, all the steps and everything for part marks in the written response. And then it's basically just like a unit exam, guys. It's just longer. Okay, you have 2 hours to write this instead of 82 minutes. All right, so it's a little bit longer. Keep that in mind, okay, because you need to be able to finish it in the time allotted, which is 2 hours. 50 multiple choice. I want to say 11 or 12. I'm getting confused with my physics one now. Written, 11 or 12 written. Okay, so let me double check that number just so I've got it for sure. Okay, so the whole test is out of 137 marks. You got 50 multiple choice, and oh crap, it's frozen. Hang on, guys. There's 87 marks in the written, and there are 15 written response. Okay, so 50 multiple choice, 50, and 15, 15 written response questions. Okay, remember also that you have to remain in the exam writing area for a minimum of 1 hour. If you are thinking you are done my test after 1 hour, you are wrong, and you should stay longer because nobody finishes that test in an hour. Okay, so make sure that you are doing everything thoroughly. Okay, you just cannot do a good job of that test in 1 hour. Okay, you guys should all be writing to like an hour and 45 at least. Okay, you should be starting to look it over by about an hour and let's say hour and 40. Okay, you should be finishing it up and kind of looking things over. Okay, going back to any questions you didn't get the first time around that time. Okay, so make sure that you manage your time on the exam effectively. Okay, that means that you should bring with you your watch. Okay, like unless it's of course a smartwatch, which probably won't. Well, it won't be connected to your phone because your phone will be elsewhere. But okay, you need something, right, to help you tell the time. Yes, there's the clocks on the wall, but sometimes it's nice to have it nearby, like on your desk or something like that, so you can keep an eye on the time. Okay, if it's been an hour and a half and you're not, kind of getting close, okay, or for sure have moved on to the multiple choice section after finishing all the written, you might be a little bit behind schedule, okay, at that point. So keep an eye on the time, okay, make sure you're getting everything finished. Okay.
How soon do we have